This module from some application of trigonometry, we are going to do a sum based on angle of depression. A beautiful sum, a very interesting one, a very simple one. The sum says that from the top of a lighthouse, an observer looks at a ship and finds the angle of depression to be 60 degree. If the height of the lighthouse is 90 meter, then find how far is that ship from the lighthouse. Now that's the sum. It's a very simple one. In the sum, we have a lighthouse and a ship, right? You can understand this. This is what you observe here. The sum says that from the top of a lighthouse, that means from the top of a lighthouse, an observer is observing something, right? This is the top of the lighthouse. But in this sum, you don't have the observer height given. That means it is to be neglected. It is just a dot, a point taken. A observer looks at a ship. He is observing a ship. Now, always remember, I have always said, the moment you have an observer, first we need to have a horizontal line. Till now, sums which we have done, the observer used to be on the ground. The ground itself used to be horizontal line. Now the observer is on the top. From there you draw a horizontal line parallel to the ground. Remember this, very critical. And finds an angle. He is observing a ship and finds the angle of depression because obviously he is looking at a lower level, lower than the horizontal line, and is observing a ship. So this is a line of sight. Now this line of sight makes an angle with the horizontal line, and that angle of depression is 60 degree. Now students, many of you tend to do mistake in angle of depression. You don't tend to draw the horizontal line. You happen to take that angle between the tower and the line of sight to be 60. So be careful. The moment you have an observer, first the horizontal line, right? And then you can make angle of elevation or depression. Easy, right? Now it says if the height of the lighthouse is 90 meter, that means the height of the lighthouse is given to us as 90 meter. If this is given to us, then they say how far is that ship from the lighthouse. That means, in other words, we need to find the distance between the foot of that lighthouse and the ship. That is what you are supposed to find in the sum, right? So you would have understood this figure, right? Now when you look at this figure further, what are we supposed to find? We need to find the length of that BC. Right, so we obviously get into that right angle triangle which contains BC. But in that right angle triangle, we don't have an acute angle in the sum. It's not there, but there is an acute angle in the sum. How are we going to use it? Observe, we have that AE and BC to be parallel, right? And we have that AC as a transversal. Now I want you to observe angle EAC and angle ACB and tell me angle EAC and angle ACB are what type of angles? Yes, they are alternate angles. You know they are alternate angles. So what can you say about these angles? What can you say about these angles? Yes, we can say that this angle, they are equal. That means we are saying that angle ACB will also be 60 degree. Now what we have is, we have a right angle triangle having an acute angle, and this is going to help us to solve the sum. Is this clear what we have done? So now when you're solving the sum further, we can write the description here as we say that what is AB? AB represents the height of the lighthouse. How much is AB? AB is given as 90 meter, right? What is C? C is the position of the ship and A is the position of the observer, right? This is what we have in the sum. And we can say that about those angles, angle EAC is equal to angle 60 degree. And we know angle EAC is equal to angle ACB. Why? Because they are alternate angles. Hence, we have angle ACB to be 60 degree. Now, consider the right angle triangle, because now in the right angle triangle, you have the acute angle which we wanted. So, now we write in that right angle triangle, observe that angle ACB for that angle ACB. Observe which side is known to us. It's the opposite side AB. And which side do we need to find? It's the adjacent side, which is BC. So we are talking about opposite side and adjacent side. And when we talk about that, the ratio which comes to our mind is what? Yes, it is tan. So we have tan to be used. So we apply tan for that acute angle 60 degree. So we write tan of 60 degree is equal to opposite side, that is AB, upon the adjacent side, which is BC. Easy. Now substitute the value. The value of tan 60, you know what is that? Yes, from the trigonometric table, it is root 3. So we get tan 60 is root 3. We know the value of AB is 90. Substitute that value as 90. Upon BC, we don't know. Keep it as it is, right? So now we want BC. So take BC on the left hand side. Shift that root 3 onto the right hand side. So now we have BC to be 90 upon root 3. Now, my dear students, yes, you would have realized the denominator is irrational. So we need to rationalize it. So when we are going to rationalize it, we are going to multiply the numerator and the denominator by root 3. Let's do that. Easy. So now what happens in the numerator? We have BC is equal to, in the numerator is 90 into root 3. And in the denominator it is root 3 into root 3. How much is that? Yes, it is 3. So we have 3 there. Do the cancellation. We get BC is equal to 30 root 3. But is it over? We can further simplify it because we know the value of root 3. How much is that? It is 1.73. So we write 30 into 1.73. Substitute that value. And when we multiply it further, we get BC is equal to 51.9 meter. That means now we can say the final answer as they wanted from us. We can say therefore that ship is 51.9 meter far from the lighthouse. And that's the sum. Isn't that easy? A sum based on angle of depression. Very simple, right?